Hello, everyone. Welcome to this webinar on structure control. My name is Jonas van Schoonstein. I'm the product manager of Nederlands Schumans Technologies. During the webinar, if you have any questions, feel free to ask them in the question panel. Leendert, please, the floor is yours.
Yes, thank you very much. Good morning, everyone. My name is Leendert van Wolfswinkel. I'm a product owner for 3DI, and I'm happy to present this morning about structure control. I will start with a little bit of a theoretical introduction, and then I will give a demo of how this works in the modeler interface. All right. So what I will discuss before we go to the demo is what is structure control, what kind of structure control is available in 3DI, and which properties can be controlled, and which variables can be measured, and how does this work. Well, structure control very generally is a technology to regulate the water system by making the behavior of hydraulic structures respond to changes in the water state of the water system. A very common example is a pump that you see here in the bottom right corner. Other examples include a weir that goes down when the upstream water level becomes too high, or a gate that opens to let water in when a downstream water level comes too low, or a calamity gate that closes when the river water level or the sea water level comes too high. So in all these cases, you see that often depending on the water level, the structure starts moving, changes, or a pump starts pumping more or less. And in 3DI, we have three different ways to do this: the timed control, the table control, and the memory control. The timed control is the most simple one. You specify a time in seconds since the start of the simulation, and then you specify a value. In this example, this is a time control that controls the crest level of a weir. So for each each point in time, you specify which value the crest level should get. Then there is the table control. For a table control, you specify the water level that is to be measured, or another variable. And then for each water level, you specify the crest level, or another variable that can be set, another property of the structure that can be set. And then the more a little bit more complicated one is the memory control. So I have created this example of a gate that is open at a specific water level, and you, in terms of the properties of this gate, the discharge coefficients are both 1. So the flow is possible in both directions. And this is the case when the water level is very low. Then when the water level starts rising, at first nothing happens, rises further, and then it passes the upper threshold, and then it is the control is activated, which means in this case that the discharge coefficients are set to 0, which means that the gate is closed. Now, later in the simulation, the water level becomes lower again. Still, nothing happens. So even though we are at the same water level as we were before, before the gate was open, then it passes the upper threshold, then the water level goes down, it's still closed, and then only when it gets below the lower threshold, the control is deactivated again and it resets to its original value. Well, I have given 2 examples so far of what kind of structure properties can be controlled. So in most of the examples, we control the crest level. In the last example, we also control the discharge coefficients, which is a very useful way to just completely open or close a structure. For weirs and orifices, it's also possible to control the gate level. And for culverts and pipes, it's possible to control the discharge coefficients and the gate level. And for pumps, you can control the pump capacity. In this image here, you see an example of what happens when the crest level is changed. So in the initial situation, in this case, the cross section is round, and the crest level is the lowest point of that cross section. When the crest level becomes higher due to a control that is activated, the entire cross section is lifted up. For the gate level, the way it works is that in the initial situation, you can imagine that the gate is above the highest point of the cross section. If the cross section is open at the top, well, the gate is just infinitely high. Then when the gate is lowered, it actually changes the shape of the cross section. Okay, and then at the other side of the control, for table control and memory control, we need a measurement. Now, in most cases, that is a water level. It's also by far the easiest thing to measure in real life. But it's also possible to measure the volume, the discharge, or the flow velocity, and use those values in your control. What you see in this image is an example of a memory control that is affected by 3 measure locations. So let's say we measure the water level at 3 locations, and then these water levels are averaged, and that average is used in the memory control. And as you can see here, each measure location also has a weight. So if you these weights, they should total 1, and in this case, they are not all as important. So these weigh stronger. Okay, then just before we get to the demo, there's something that is important to understand to follow what I will be doing, because there are 2 points in the process where you can add structure control to your simulation. The first one is to define it already in the schematization. So here at the left, you see your structure control. You add this to your schematization. And then when you make a 3DI model, this information will be extracted to your simulation template. And then when you start the simulation, well, of course, you select the simulation template so that structure control is included. And of course, much of the information in your schematization is extracted into your to make a 3DI model, and that is also used in the simulation. The second way is to define the structure control after the 3D model and the simulation template have been made. So you don't need to specify it already in the schematization, or you can override what you have done in the schematization. And instead, when the simulation has been made, you add the structure control and then you start running it. I will also demonstrate both of these methods. Okay. For the demo, we have a case of Regina, which is a city in Canada. I think, if I remember correctly, it's the capital of Saskatchewan or something. It's a pretty big city. And what we have here is a river, and there is a discharge wave that goes from upstream to downstream. It peaks at 24 cubic meter per second. And here downstream, it causes some problems. So if we look at the maximum water depth in the situation without structure control, we see that this area is flooded, and there is a park here with some paths, and we don't want that to happen. If we go a little bit further upstream, let's see. Here we have an area that has a little bit more space. Is a little bit lower, and there is a weir at this location. And the idea of the city council is that this area can be used to store water if the water level downstream becomes too high. So what we want to do is to raise the crest level of this weir if the downstream water level becomes too high, and then find out if that actually solves the problem, and also find out if it doesn't cause new problems upstream. And the first approach we will take is to measure the water level here and then add a table control to this weir. Okay. So we start by adding a measure location to this connection node. Yeah, so I want to measure the water level, and I can add a display name, for example, measuring station downstream. Then the next step is to add a table control. Well, the target type you see here is weir because I clicked on the weir. The ID is 2 because that's the ID of the weir that I clicked. Well, we need to choose an action type. We want to set the crest level, and we need to choose a measure operator, and we choose the larger than. So that means that if the measured value exceeds the value that I fill in here, then the action value will be applied. Well, there has been some previous calculations, and for a downstream water level of 565.4, we would need a crest level of 566, etc. Well, Yeah, I have this in a text document, so I can copy it and then paste it here. Okay. And then the last thing we need to do is to connect the measure location to the table control with a measure map. So go from here to here. And give it a weight of 1 because we only have a single measure map. The control type is the table control, and that has the ID 1, so that's all fine. We save our edits. One thing you need to make sure is that you go to the settings and check the simulation template settings, because there is a checkbox for using structure control. This checkbox is checked, so we're okay. If you schematize the entire structure control, but you forget to check this button, it will not be used in the simulation template. So don't forget that. And then sorry. Yeah, we have saved all our edits, and we can upload the schematization. New upload. Yeah, of course we will check the schematization. Yeah, it has a lot of warnings that I still should solve, but there are no warnings or errors that relate to the structure control. So we will upload this revision added table control. Yeah, upload it. Okay, so we for this webinar we're not going to wait for this process to finish. I already uploaded this previously. Let's see what we have. Yeah, so this revision 15 already has this table control. And if I start a simulation with that, you will see that in the first window of the simulation wizard, it says, yes, please include structure control. Say table. Table control. We simulate for 1 hour. No, sorry, 1 day. That should be. Yeah, we also want to use this discharge wave that peaks at 24 cubic meter per second. So I created this CSV file that contains this 2D boundary conditions with this discharge wave. And I want to use the structure controls that are in the simulation template. Yeah, as I explained in the PowerPoint presentation what is in the simulation template that was extracted from the schematization file. If you want, you can also combine it with additional structure control that you upload here, or you can uncheck this box and only use an uploaded file. In this case, we just want a schematized table control. This is all fine. Now we start the simulation. Again, for the purpose of the webinar, the simulation takes about 10 minutes. So I have already simulated this before and downloaded the results. So we don't have to wait for that. So let's see. We load the baseline result and we use the table control result. Okay. Yeah, and then the first thing I will do is to go to the location where the weir is and check if the weir crest level has actually been affected by the structure control. Let's see. Okay, so I clicked. I used the time series plotter.
The pop-ups are not showing on the.
Okay. Yeah, so here I can select the crest level as a variable. This is only available if there is structure control at this location. And as you can see here, this simulation, I will hide the other one. The one without structure control, it will not show anything in the graph because the crest level does not change. The other one with the table control, it shows that after about 4 hours, the crest level starts rising, and you actually see the table increments that I entered. You will also see them in the graph. What you will also see is that there is a feedback. So at some point, the crest level becomes so high that it affects the downstream water level to go down. And then because it goes down, the crest level goes down as well, which makes the downstream water level go up. So there is a kind of feedback loop. At some point, the water level becomes so high that it's not a problem anymore. But when the water level starts getting lower again, you again get these fluctuations. That's probably not super desirable. Okay, so and we also want to know well, what is the effect, for example, on our maximum water depth downstream. I will hide this. So this is the water depth without structure control, and then with the table control, well, you see very slight differences, but it's almost non-existent. So the table control is not super effective. Well, is that because nothing really happens? If we look at the upstream situation, we can see that the table control actually causes a lot of extra storage upstream, but it doesn't really solve the problem downstream. Well, then I will give an example of how to schematize the memory control. Let me hide the results again. Okay, so let's delete this this table control. And instead add a memory control. Yeah, so the first thing to fill in is when does this memory control need to be activated? Well, as an upper threshold, we want it to be activated when the downstream water level becomes higher than 566. And we use a deadband of 0.5 meter, which means that it will not immediately give this feedback effect. The water level downstream really has to become 0.5 meter lower before this memory control will be deactivated. So 5.5. Okay. Yeah, we don't want it to be inverted. We also don't want it to be active at the start of the simulation. It needs to become active when this water level is exceeded. The target type is the weir with ID 2, so that's good. The action type is to set the crest level, and the action value should be, let me see, 569. Okay. We don't have to fill in action value 2. That's only relevant if you want to set the discharge coefficients, because well, there's only one crest level, but there are 2 discharge coefficients, one positive and one negative. So it's fine to just fill in number 1. Okay. Then we also need to adapt the measure map, because that still refers to the table control. So we let it refer to the memory control. The control ID is 1. I think that's yeah. So this ID 1. Check, double check. Yeah. Okay. Then we save the edits. Well, again, we can upload this as a new revision, and then do a simulation with that. Let me check. Okay, I will just skip forward to having a look at the results. How does this memory control behave? I'll add the results for the memory control simulation. Okay. Zoom in a little bit. Okay. So now we have the no structure control, the table control, and the memory control. And I want to visualize how the crest level changes. No, this one is not super relevant. I will disable the table control. And now we can see that the memory control is much more stable at the when the water level is rising. It only changes the crest level once, and when the water level is lowering again, there is some feedback with the downstream, and it changes 2 times, but it's yeah, not as peaky as or the oscillation is much less than the table control. Yeah, then these are the two possibilities that you have when adding structure control to the schematization. The timed control is not available in the schematization, but it is available in the when you start the simulation. And I will continue with demonstrating that. Well, as we saw when we had a look at the maximum water depth, the table control was not effective. And one thing we can do is to make the table control, to let it set the crest level of this weir even higher, so that we have even more storage upstream to see if that in the end reduces the water level downstream. But we don't want to make a new schematization every time, because the model doesn't change. We are basically editing scenario information. So what we can do is we go to the management page. Sorry, management.3di.live. We find our simulation. So this was the simulation with the table control. And here you can see the events. We have a file for the boundary conditions, and we have a file for the structure control. And we can just download the structure control files. Let's see. Okay. Yeah, and this file may be a little bit impressive if you see it for the first time, but if you have a closer look, it's not that complicated. It contains all the memory controls. Well, there are no memory controls in the simulation. Then it contains a list of table controls, which actually only has one in this list, but you can, if you want, you can add multiple, and it includes a list of time controls, which is also an empty list. Well, the table control list has one item. It has an offset. It starts at time step 0. It has a duration. Well, this is just the entire duration of the simulation. And then it contains a measure specification. So again, which type of object do you want to measure at? Well, at the connection node. What is the ID of this connection node? And what is the weight of this measure location? Please notice that you will have to include the v2 prefix. This is also noted in the documentation. If you omit this, it will not work. Then you specify what do you want to measure. Well, S1 means water level. You can also find a list of these variables in the documentation. And you want the larger than operator. Then next is which structure. So we want to add the control to a weir with ID 2. The action type is set crest level, and then you have the table of the measured value and the action value. So this is all the same information that we entered in the schematization, but in a bit of a different format. And what we want to do is here the maximum crest level in this table is 569, and we want to increase it just a little bit. So we'll say if we make it 569.5, and we add another table entry. Not make the steps too big. So 5.9. This. Okay. And we save that. Now, then we will start a new simulation. Revision 14, we will use the default template. We want to include the boundary conditions. We want to include the structure controls. Table control with higher max crest level. Simulate for 1 day. Upload our boundary condition file. Which one did I use? And then we don't want to use the structure control from the simulation template. We want to upload our own file. And that was the one that I just downloaded and edited. Initial conditions as they are, settings as they are, and then we start the simulation. So this method actually makes it much easier if you want to do to test things out. It makes it much quicker. It may take a little bit of time to understand how to edit this this text-based JSON file, but I think once you have done it once or twice, it's pretty clear. And also, if you use the method that I showed, downloading an existing file from the management page, you already have a complete file, and it's you can just edit a few numbers. The last thing I will show is how to use the time control, because that is something that is not possible in the schematization, but you can add it to the simulation when you run the simulation wizard. Let me see the documentation. So we go to the user manual of the modeler interface, to the simulating chapter, and then in the structure control paragraph, we there's the option to upload the file, and then for each type of control, you will see documentation of all the parameters that are included in the file, and also a text example. So we just copy paste this timed control example. Paste it here. Okay, so we want it to start at 0. We'll just copy the duration from the other one. Then we have the values. In this case, we want only a single value. Let's say we use just maximum crest level. And as the action type is set crest level, and you can just copy paste a lot of these. Structure type is a WIR, and structure ID is 2. Okay. Yeah, and let's say we want this time control to become active after 5 hours. Then the offset is now 5 times 60 times 60. How much is that?
5 times 60 times 60. 5 times 60 times 60. 18,000.
18,000 now. Okay. So 18,000 seconds, that's 5 hours. Then the time control will become active and it will set the crest level of the weir with ID 2 to a crest level of 569.5 meters. Okay, we will save this table control.
Timed control, right?
Timed control, sorry. As a JSON file. Yeah, make sure to save it as a JSON file so that the simulation wizard understands it. And then yeah, I'll use this template. Boundary condition, structure control. Short P. Yeah, I already have the correct boundary conditions in this template, but I will remove the structure controls that are in the template, and I upload my timed control file. I should also change the name of the simulation.
Back to structure control. You wanted to change something though?
No, I have uploaded the timed control JSON file there. I think we're fine. Okay. So yeah, with this second method, it's quite easy to do a lot of different simulations, trying out different settings for a structure control. Maybe to wrap it up, let's have a look at the result for the table control that has a higher crest level. So, well, we can see in the maximum water depth that upstream is actually pretty severe. There's a lot of flooding. For example, here it even reaches, it gets pretty close to some of the buildings here. So yeah, this is probably not something you would want for the upstream situation. Is it effective downstream? Well, a little bit. I think the park and the path that we have here is still kind of dry, but it's yeah, the effect is downstream is very small. So I think we can conclude that having this specific configuration of a structure control to solve the flooding problem here is a bad idea. I think that's the demo.
Thanks. Oh, maybe I should put on my camera. Yeah. Okay. Thank you for the demo, Leonard. We have a few questions. One is the change in crest level for weirs also visible in the side view tool when looking at the results? You've shown the graph tool, but in the side view tool, you can also see the crest levels.
Yeah.
Are they there also for the structure control?
No, that's it's a good question. That is definitely something we could try to incorporate, but no, it's not implemented at the moment.
Okay. And there was a question about the time control in the model interface that was earlier during the webinar. I'm guessing that question has been answered. Where can we find the time control in the model interface? I think you already said it's not in the model interface, or you said it's not in the schematization. And I think the question is referring to the fact whether it's in the schematization or not.
Yeah, maybe also there is reasoning behind that. So in principle, what you put in the schematization is are all the things that don't change very rapidly over time. So, for example, the size of a pipe, it's a fixed attribute of your model area. The timed control, by definition, it's not fixed because it happens at a very specific time. While a table control and memory control, those are basically fixed rules that are always applied. So that's the logic behind it.
All right. I have some other questions. You said at some point I have structure control added to my schematization. Then I went to the settings. You went somewhere in the model settings, I think, and you turned on the structure control. Is there also a check in the schematization checker that warns you if you have added structure control to your schematization and you are not using it?
Yeah.
So there's a warning, or
yeah.
Okay, perfect. I was wondering about that because it would be horrible if you would do all that and not use it. Of course, you will see it in the results, but yeah, then you are 10 minutes further in time. So
yeah.
You also are showing about the action values for the discharge coefficients. You said you have action value 1, action value 2. Just a follow-up question on that. What you mean is that the action value 1 for the discharge coefficient is the positive drawing direction of the pipe or feature, I guess.
Yeah.
And then value 2 is for the negative direction, right?
Yeah. Okay. Yeah, that's correct. Yeah. So I can.
Perhaps it's also written down in the documentation, but I'm not that familiar with this part of 3DI, so hence my.
Yeah, that's a very logical question. So for this weir, if you want to completely close it, you would set the discharge coefficient to 0, and to know which of the two discharge coefficients you want. Well, in this case, the water flows from east to west. There is a style to show the drawing direction. So, often these schematization objects are schematized in the direction of the flow. That's also the case here. So a positive discharge coefficient set to 0 would mean that water would no longer be able to flow from east to west in this case.
All right. Maybe also a question to the audience. In this case, we have not shown any structure control options using the API. If you are interested in that, feel free to reach out to us after the webinar. And if there are sufficient people asking for it, we can also host a webinar on that specific topic. I saw you had it also in your script, but there is not enough time to do that, and I think it's almost a full webinar to completely show how you actually use the API for structure control. Let me see any other questions that have not been answered yet. Yeah, one last question. What happens if you have conflicting structure controls? Because you can have like one in the schematization, so that is in your simulation template, and you can also upload a file. Who wins?
Yeah, they all win. Okay, so if we have a look at this file again, as these brackets, they mean that there is a list. So you can actually have multiple table controls at the same time, and they can also be added to the same structure. So the same weir that we have been using, we could define multiple table controls for that weir, and also multiple memory controls, etc. And if they well, usually you don't do this for the exact same measure value, and they will so yeah, they will be applied one by one. If they have the same measure values, then I don't know exactly what will happen or what the sequence will be, but it's also a bit of a strange.
It can happen by accident.
Yeah.
I'm guessing. So you will probably see it in the results. I'm guessing in the graph tool, unexplainable behavior, and this might be the cause for that, I guess.
And that's also why it's, as I did in the demo, once you load the results the simulation and you want to understand how did the structure control affect my simulation, it's always a very good idea to go to this structure and make a graph, for example, the crest level in this case, to see how did it behave.
Yeah.
And if you have multiple controls affecting the same property, then obviously it makes it's a good first step when analyzing results.
All right. Thank you very much for this presentation and this demonstration. I hope that for everyone following it, it is clear what are the options for structure control in 3DI and how to apply them. Yeah, that's it. See you at the next webinar.
Thank you very much.